Okay, so let's get started. So, okay, yeah. So this is very interesting problem. If you are able to solve this problem, so if you are able to solve this problem, then I think you can understand stack more than 70%. So let's understand the problem statement. Uh, so you will be given histogram heights. We need to return longest rectangle histogram. So let's understand the problem statement. So you will be given histograms heights in the form of an array. So the array is 2, 1, uh, 5, 6 and 2, 3. So these are the histogram heights. We need to return the longest histogram. So let's see here. So the first height is 2. Width is always, for each histogram width is always be 1. So first height is 2, so this is 2. Second height is 1, okay, so this is 1. And third one height is 5, let's say it is 5. And fourth one height is 6, so which is 6. Fifth one height is 2, so let me take it as 2, so this is 2. And sixth one height is 3, so let me take it as 3. So this is the longest histogram heights. For each histogram heights were provided. So we need to return which could be the longest. We need to return the longest rectangular histogram which you can make. So let's understand how do you make a rectangular. So in the rectangular, so this width will always be equal, right? Correct? Yes or nobody? Yes or no?
Yes. Yes.
So let's understand the problem statement here. So this is what you have. So you are given an array. The array is representing histogram heights. So this height is 2, this height is 1, this height is 5, this is 6 and this is 2 and this is 3. So we need to return the longest histogram. So this is 6. This is 3, so let me erase it, erase the bottom. Okay, so what I'll do, let's see how what are the possible rectangulars you can make here. Then we need to return the longest area. Let me do that. So if you closely see, if I start from this index, so this is at index 0, 0, 1, 2, 3, 4, 5, right? So if I start from this index, so I cannot extend further more. So this is going to be my longest rectangular. So I cannot extend further more. So this is going to be my longest rectangular. But obviously, why you can't extend further? Because the part, if you closely see, so if I see this one, so this is only the rectangular I could make. So I cannot extend further because the right part is smaller, right? So if it is larger, you could have extended it. So obviously here you will get only the max area you could get here is 2. Okay, so if I start from here, it is 2. So let's say if I start from here, so if I start from this point, so this is my indexes. So let's say you have indexes as 0, 1, 2, 3, 4, 5. So let's say I'm starting from index 1. If I start from index 1, if you closely see, I can extend left, I can also extend to the right. So till last I can extend. So this is the largest rectangular I could make. So if you closely see, the size could be 1, 2, 3, 4, 5, 6. So because the width you could make is 1, for each rectangular height is 1 and the width is 6. So 1 into 6, which is going to be 6. So that here the area you could make is 6, because this is what the area you are going to cover. Let's say I start from 0, 1, 2, 3, 4, 5. Let's say I start from index 2. So if I start from index 2, closely see here, so this is my index 2. So I cannot extend left because left part is smaller, so but I can extend to the right. So this is the area I could cover. So each height could be 5, and the width you can find is 2, because 1 and 2, so which is going to be 2 into 5, so you will get as 10. So let me update that. So if this is the case, so this is the rectangular you could make. So it is going to be 2 into 5, so which is going to be 10. Now if I start from here, let me take other copies too, so that, let me update here, 0, 1, 2, 3, 4, 5. Okay, so let's say I will start from index 3. Okay, so you are starting from index 3. So if you closely see, if you are starting from index 3, so this is the height you have. If you closely see, you cannot extend right, you cannot extend left, because all are smaller. So that this is only the rectangular you could make. So with width 1. So obviously which is going to be 1 into 6, so you will be have 6. So here the area you could get with 3, so 1 into 6, which is going to be 6. So let's move further. So I'm trying to start from 4. So let's see here. If I start from 4, let's see what are the areas we could cover. So I can extend to the right till here, to the left till here. So this is the area I could cover. And if you closely see, the total width you could see is 4, because 1, 2, 3, 4, 4 into 2, which is going to be 8. So if I start from index 4, so which is going to be 4 into 2, so which is going to be 8. Now if I start from index last index, so anyhow I can't extend right, but I can extend to the left. Even I can't extend to the left, because left is smaller. So this is the rectangular I could make. So that obviously the size you could make is this one. So that obviously which is going to be 3 into 1, so which is going to be 3. So if you closely see, if you see all the possibilities, right, so this is what you could see from here. If you closely see all the possibilities, 8, 3, 6 and 10, so 10 is the max answer, so we need to return the max rectangular area, so which is 10. So is the problem statement clear? Ajay, Kalyan, it's not clear. Ajay, isn't it clear? Ajay, you are on mute. Kalyan, it didn't clear. Can I explain again?
Not I mean, for one, how we are taking from one to the till the last, right?
How do you
That's
make a
why.
rectangular? How do you make a rectangular? If the width is equal, right? If you can extend
Yes,
the width is equal, right? If you
yes,
see, when you start from 1, I can extend till the last, na? And I can
yes,
also extend to the left as well, right?
correct.
So this is the part I could cover, right?
Yes,
So
correct.
with
Okay.
height
That
1, and you have 6 blocks, right? So it is going
okay
to be
one.
6 into 1, so which is going to be 6, right?
Yes, clear. Yeah. No, it's clear. Yeah.
When it comes to second index, so you have height 5. You can't extend left, because you can't make a rectangular by extending left, because there is no bar on the left side, na? But you have a
Correct.
bar on the right side. So that this is the rectangular you could make with height 5. Then definitely you will have width as 2, so 2 into 5, so which is going to be 10. So when it comes to here,
Shrinu, but what if there is one more item there having a height of 1? Then in that case,
then that
uh,
will be covering here, right?
yes,
Yeah, so let's
yes,
say,
yeah, go on, go on, yeah.
here, so you have 6, height as 6, right? Height as 6. Can you make a rectangular furthermore with height 6? You can't move
No.
right, you can't move left, because they are smaller size, right? So definitely this is what the rectangular you could make, so that it is 1 into 6, which is 6, right? That's your answer is, your question is addressed here, na, Ajay? So you have 6 here, you can't move right and you can't move left. So obviously When you are here, you can move left with height 5. If you closely see with height 5, what is the rectangular you could make? You can move to the right, so that but you can't move to the left. Why? Because you have 1 here. That's why you get width as 2. So 2 into 5, which is going to be 10.
Got
Now,
it. Yeah.
now where is it? Okay. So now when you are here, right? When you are here, you are at 2 now with height 2. Can you make how, what is the rectangular width you could make? So you can move to the right once and left twice. So this is the rectangular you could make. So there are 4 blocks, so that 4 into 2, which is going to be 8. And with height 3, so what is the rectangular you could make? So you can't move left because left is smaller, so that you can't move right because there is no right. This is only the height you have, so which is going to be, this is only the block you have, so 3 into 1, so which is going to 3. So out of all these uh, so you have only one max area, so which is 10. So 10 is the expected answer. Problem statement is clear, right? Because for this, problem statement is more critical. So if you understand problem statement, then we can think about solution.
Yes, sure. No, it is clear.
Yeah. Kalyan, it's clear, na?
Yeah, it's clear.
Now let's move on. So how do you understand that, right? So how do you understand? So if you closely see, this is the input which is given, right? So 2, 1, 5, 6, 2, 3, right? So this is at 0, 1, 2, 3, 4, 5. So these are the indexes. Okay. So how do you figure out a rectangular now from the current height? From each index level, from each index, what we did with the given index, what could be the maximum extendable rectangle you can make, right? So how did you figure that out? So I'm at index 0. So when I'm at index 0, what could be the maximum rectangular I could make? Only one.
It's
One
Only
with
smaller.
one.
height 2, right? One with height 2. So maximum rectangle, one with height 2, so which is going to be 2. It means width is 1 and height is 2. So 1 into 2, which is going to be 2. But when I'm at index 1, right? What I'm doing with height 1, what is the maximum rectangular I could make? So if you closely see, this is what happening, right? So with height 1, uh, okay, so with height 1, so what is the maximum rectangular I could make? I can extend till to the last, and I can also till extend to the left last. And I found that there are with I can make a width as 6, so which is going to be 6 into 1, so total is 6, right? How did you understand that? How did you understand? Now when I come to 5, right? So when I come to index 2, so here the rectangular height is 5, right? With height 5, what could be the width I could make? I can't extend to the left because left is smaller, but I can extend to the right. Then I extended till here. Then I found that width is 2, so 2 into 5, so which is going to be 10. How do you confirm that? From index 2, I cannot move left, but I cannot move left, but I can move to the right only to index 3. How do you confirm that?
By checking the previous index value with the current index
Mm.
value.
Mm. Yeah. What is that value? What is that condition? So
I
how
mean,
are you able to extend the 5 to the right?
Because value
because
of 5 is less than 6.
6 years.
Yeah. So some similarly, so it means, what does it mean? So for example, when it comes to 2, right? How do you know that 2 can be extended till here and 2 can be extended to the left and right as well?
Because they are greater than index 4.
Yeah. Now you understand, right? So now can you tell me how do you find out a max area from each index level?
If you know the left and right heights,
Hmm.
then you can. um,
So let's say here you have, let's say you are at index 2, right? So how do you know that? Can you tell me? I wanted to hear from you. Okay, so let me explain. So you are at index 0, right? So at index 0 you have value 2. Okay, so what did you understand here? What did you understand here? I need to find out what is the previous smallest element and what is the next smallest element, right? That's it now. So if you closely see, if you closely see, when I am at 5, right? When I am at 5, I need to find out what is the next smallest element index. Okay, this is the next smallest element index with respect to 5. What is the previous smallest index? So this one. Correct, nobody? For for element
Yes.
5, the previous smallest index is this one. For element 5, next smallest index is this one. Between whatever elements you get, what is the count you get, right? That count into this height only, no? Correct?
Yes.
So what did you understand here? For each index, we need to find out what is the next uh, smallest element index, what is the previous smallest element index, right? So when it comes to 2, so uh, you don't find any previous. So obviously, because this is the first element, do you find any next? Okay, do you find any next? No, right? So do you find any next? No. So but next smallest index is 1, previous smallest index is nothing. So that, let's say you have -1. So if it is 0, let's say you have -1 is the previous smallest element index. So this is next smallest index and this is previous smallest index. Okay, or else without solving this, let's say you want to come up with brute force solution. Without knowing that, let's say you want to come up with the brute force solution. So how do you know that? So you are at index 2. Okay, so I am at index 2, I am at index 0. I want to find out anyhow. Always I will consider the current element, so that this for index 2 the counter is 1, and I need to find out a left counter. How do you find out the left counter and right counter? What do you mean by left counter and right counter here? So with respect to index 2, we need to find out, is there any, can I extend this index 0 to the left? I cannot extend index 0 to the left, so that left counter will be 0. Can I extend this index 0 to the right? I cannot extend to the right. Why? Because immediate right is 1, right? So immediate right value is 1, which is smaller than the current element. So obviously I cannot extend to the right, so that the current, obviously left is 0, right is also 0. So obviously you will always consider only the current element. So current element, which is 2, and 2 into, always consider current element. So 2 into 1, which is going to be 2, because left and right are 0. Now let me explain for next element, so things will be more clear. So when I am here, right? So when I am here, can I extend to the left? Can I extend to the left?
Yes.
Why? Because if you traverse to the left element is 2, so which is greater than 1, right? Which is greater than 1, right? So that I can extend till here. Similarly, find out what could be the right greatest element, so that I can extend till here, right? Yes or no? I can extend
Yes.
till index 5, right? So I can extend till index 0. So if you closely see, so to the left I found 1 element, to the right I found 4 elements. Correct, na? Yes or nobody? To the right I found,
Yes.
to the left I found 1 element, to the right I found 4 elements, and I'll also consider current element. So 1 plus current element count plus right count element, which is 6. 6 into current height, which is 1, so which is going to be 6. Correct, na? So that I could get 6 here. Correct? Correct?
Yes.
So when
Yes.
I am here, right? When I am here, can I find a left?
No.
No. So
Yes.
left will be 0. Can I find a right? In the
Yes.
right I find 1 element, right? Correct? Right is
Correct.
1 element, left is 0. So that 0 plus 1 plus current element is 1, so which is 2. So 2 into 5, so which is going to be 10. So you got 10 here. When I am here, can I find a left greater elements?
No.
No.
Right greater elements? No,
No.
right? So that you will always have 6 into 1 only, which is going to be 6. Now when I am here, right? So if you see from here, how many elements you find greater than 2 on the left side?
Two elements.
Two elements. On the right side, one element,
One.
right? So 2 plus 1 plus current element, so 4 into 2, so which is going to be 8. Now when I am here, so here left is 0, right is also 0, because 3 into 1, then you will get 3. So it means from each index, what I am trying to say, from each index, you need to find out how many elements greater than this to the left and right, and just find that counter and the total count into current element. That's it. So you will get the area from that index. So once you know the area from that index, you keep on update max here. Clear, nobody? Brute force is
Yes.
clear.
Yes.
So now if I walk through it, so when I'm here, so definitely there is no left and right. So it obviously initially max is 0, so you will get 2 here, max will become 2. So when I'm here, left is 1 element, right is 4 elements, right you have 4 elements, left you have 1 element, and the current element, so definitely 6 into 1, which is going to be 6, so max you update to 6. Now let's move further. So let's move further. So when I am here, so left is 0, but right you have 1 element, and this current element will be considered, so which is going to be 2 into 5, so you have 10. So max is going to be 10 now. Now let's move further. So when you are here, so left is 0, right is also 0, so there are no elements found, so you only consider current element, so 1 into 6, which is going to be 6, max is 6, so which is greater, so that there is no update. Now let's move further. So when you are here, so left you can extend till here, right you can extend till here. So left you found 2 elements, right you found 1 element, and the current element, so which is 4 into 2, 8, and which is less than the max, so that no update on the max. Similarly for this, so there is no left, there is no right, so that obviously current element, so which is 3, so you will always have a max, so you will return the max. So what is the time complexity here? What is the time complexity here, please? What are you doing from each index, for each index?
You're traversing left. You're
Left
traversing
and
right.
right. So how many elements you traverse for each element?
N minus
In the
1.
first
So it
case,
means,
it can be
yeah,
n minus 1.
so it means there are n elements and n minus 1, so definitely it is going to be n square, right?
Yes.
All right. Yes.
So what is the space complexity?
You're not taking any decimal space.
So which is going to be constant, right?
Constant.
Uh,
Yes.
Okay, so let me write a brute force so that we can further optimize it. So then you will understand. So what I'm trying to say, so simply you will have max area, so which is initially 0. And what is our job? So this is my current index, and index less than, let's take n here. Integer n as heights dot length and index plus plus. Okay, so now initially you always consider the current element, so that counter is 1. Then what you do, we need to find out left index. So left is going to be index minus 1, and right is going to be index plus 1. So we need to find out left and right pointers and find how many elements you find on the left and right. So let's say as long as my left is greater than or equal to 0, and my current left, right, so whatever left I have, so nums of left, it is height, right, so this is my current left. If my current left is greater than or equal to this whatever current index you have, so height of index, it means you can extend this to the left, so that I can increment the counter. Then I will just do left minus minus. Is this clear? So
Yes.
so similarly for the right, what you can do, so this is my right, so right is less than n, then my current right, if it is greater than or equal to current element, you can increment the right counter, then right plus plus. So it means this counter is holding left and right, so you will just keep on. So the initially it is having 1. Then what is your job now for this bar? So math dot max of max area comma for
Counter
this
into
bar,
height
right?
of
So yeah,
index.
so counter into height of index. Okay, so height of index. So let me run.
We're not returning.
So that's it. So if I submit, definitely it will give time limit. So what is the mistake we are doing here?
Two values.
Yeah, while loop means what are you trying to do? So you are trying to
Like
find out.
passing and
So
like going.
this is causing more complex. That is increasing the complexity, right? For every element, you
Yes.
are blindly to find out left and right. So in worst case, which is always taking n. So how do you improve that?
Can we have two stacks, one for left and one for right?
What is that stack? Okay, for left, which stack you maintain?
The mm, the values which are left to the index.
Okay, so let's move on. So this is your input, right? Okay, so this is your input. What is it? 215623. Okay. So 215623, and you have indexes as 0, 1, 2, 3, 4, 5. So the problem also we understood, right? So what are we trying to do? So we are trying to figure out for a given index what is the smallest index on the left side, what is the smallest index on the right side, and prior to that whatever values you have, you just consider that and you figure out an answer. Now that is making the complexity, right? So that is increasing the complexity. Now what I am going to do, right, for each index to find out what is the next greater element. So one is we need to find out what is the next greater element for each index, and what is the previous greater element or next smallest element. Okay, so if you closely see in this case, what are we doing? To be precise, so to be precise, if you closely see in this case, right, we are extending this bar, right? So we are excluding from a given index, we are excluding previous smallest index and next smallest index. Between whatever you have, you will consider, right? Yes or nobody? To 5, this is going to be next smallest index, right? Yes or nobody?
Yes.
And to 5, this is going to be previous smallest index, correct? Yes or no?
Yes.
So this is previous smallest index, this is next smallest index, right? So let me copy this so that things will be more smoother. So it's time to find out that. Okay, so I have a bar 5. I have a bar 5. So this is our previous smallest index, and this is our next smallest index, right? So if you closely see, what is the previous smallest index? 1. So you guys say previous smallest index is 1, and next smallest index is 4, and we need to find out the between count. So you can count actually the between count, which is 2, right? So you can find that 2 next smallest index minus previous smallest index minus 1. So if you closely see, 4 minus 1, what is it?
Minus one again.
Yeah, minus 1. So you will get 2, right? So definitely this is what the expected answer, right? So of course this finding out this principle is a matter of practice, or you can also find through counter also, but let's make it in a standard way. So somehow we need to find out for each given index, we need to find out what is the next smallest index, what is the previous smallest index. And once you know that, then simply you can find, apply this, you will get the counter. So counter into height of that particular index, then you will get the area, then you can manipulate on the max area. Correct na? Correct na, buddy? Ajay?
Yes.
Yeah. Now, how do you find out, right? So there are two cases. So we need to find out this next smallest index and previous smallest index in constant time. So how do you find out? So that's the tricky part. So let me copy this. Okay, so I want to find out. So definitely what I'm going to do, I'm going to maintain two arrays. So I'm going to maintain two arrays. One array is representing say of same size, so 0 1 0 1 2 3 4 and 5. So this is going to represent the next smallest index for a given index, and similarly you have previous smallest index for a given index, so for each index. So definitely you will have same thing, so 0 1 2 3 4 and 5. Okay, so now let's see. Actually, when you are at zeroth index, right? So you don't have any previous smallest index, so that let's consider it as -1. When you are at last index, you don't have. Okay, this is next, right? So this is next. So when you are at last index, so there is no next greater element. So definitely you can consider it as n. So n plus 1. So which, let's consider it is 6, because there is no element after that. And when you are at 0, so there is no previous element, so let's consider it is -1. This is length plus 1, so you have -1 and +1. Now somehow we need to fill these values, remaining values, so that you can find out you can easily find out the area. So how do you find out next greater element? So let's find out next greater index for a given index. So something like we already solved the problem next greater element, right? So for this, what is the next greater element, right? So for this, there is no next greater element. Obviously, you will have length as 6. Now you will consider this, right? So you know that for index 4, the next greater element is at index 5, right? So because 3 is greater than 2, so that I can directly take this index. How do you know that? How do you make it, how can you do that in constant time?
By traversing the list.
Yeah, so we already solved it, right? So let me solve that. So what we do, for each index, what is the next greater index, right? So we just need to find that. So definitely, if you closely see here, so you have index 3. For index 3, there is no, let me calculate this. So for index 3, definitely you don't have next greater element, so that definitely it is -1. So let's understand, as we solved it, we already solved it. Let's understand that way. So at index 3, you have index 3 at the stack. Now let's move further. You are at index 4, you have element 2. You see in the stack you already have 3, so 3 is greater than 2. So generally in the stack, what we do is, instead of maintaining the elements, let's maintain the indexes, so that finding the answer becomes easy. So you will have indexes. So initially you have an index 5, the value you have is 3, right? The value you have is 3. So for 3, there is no next greater element, so that let's say you have -1. So let's keep it as -1. Now when you come here, so you are here, so you have element 3, element 2, so which is smaller than, in the stack you have element 3, right? So which is smaller than that, so that you can understand that for this 4, the next greater element is 5, so that index is 5. So index we store, okay? So please understand that. So we store index, so which is 5. So as it is index, that's why what I'm saying is, for last one you don't have next element, so the -1 is representing length plus 1. So you just, because when you apply this formula, it will be smoother. Otherwise you can have minus 1, that is fine. Now when you come here, right, so when you come here, if you closely see, do you find next greater element? So how do you know that? So obviously, when you are at index 4, you compare with index 5 value, and index 5 value is greater than index 4 value. So that for index 4, the next greater index is 5. Now what you did, so you I forgot to add that index, so I added index 4. It has the value as 2. Now I am at index. Now I am at index 6, right? So when I am at index 6, so let's understand, do you have a next greater element? So definitely you see index sorry, I am at index 3 having value 6. 6 is greater than 4, so that obviously I can delete this because this is smaller than 6. Then again 6 is greater than 5, so that I can, sorry, 6 is greater than 2, so I can delete this. 6 is greater than 3, I can delete this. It means I deleted both the indexes. Now stack is empty. It means for 6 there is no next greater element, so obviously I will maintain minus 1 here. Okay, so let's go in the same way. I'll maintain minus 1 here. Now let's move further. I am here. So what, before moving to previous index, what you do, you store the index, and for our clarity sake, I am just representing the value here. Okay, so when I am at 2, if you closely see, for 2, next greater index is 3, because index 3 is having value 6, which is greater than 5, so that you can always keep that 3. Now I move further. So before moving further, I will store the current index, and its value is 5. Now when you move further, so if you closely see, for index 1, for index 1 yeah, so for index 1, the next greater element is 2. So because the next greater element you could see is 2, so that you can consider 2 here. So you can consider 2 here, and you will have sorry, we went in wrong direction maybe. What is our purpose here? What is our purpose?
Smallest index.
We are trying to do a
Largest.
largest index.
Yeah.
Okay. Of course, it went out of sync now. Let's do it again, no problem. So 1 is 2, 1, 5, 6, 2, 3, 0, 1, 2, 3, 4, 5, 5. Okay, so let's find out next smallest index. Okay, so okay, so I want to find out next smallest index. So obviously when it comes to 3, so there is no next smallest index. So obviously let's keep let's keep the value as 6, because it will, for example, if you closely see, you don't have anything to the previous as well, right? So definitely for the previous it is 4, previous smallest index is 4, next smallest index is 6, 6 minus 4 minus 1, so which is going to be 1. So just to satisfy this principle, for the last element, if there is no next smallest index, so which is going to be n plus 1, so you can just keep the, so obviously for the last element, which is always going to be n plus n, so the length of the array. So similarly for 0th index, previous smallest index is going to be minus 1. So just to satisfy that principle. Okay, now let's move on. Now when I am here, right, when I am at index 2, when I am at index 2, so what is the next smallest? So what I will do, so first, before moving on to previous index, I will store the current index in the stack. In the stack I will have a current index, and it is holding the value as 3. Okay, so let's move on to previous index 4. At index 4 I have value 2, and I am comparing with index 5 value, so which is 3. So I want to find out a smallest index, right? So that when you want to find out a smallest index, so that you don't need larger values in the stack. So that obviously the current value which is present in the stack, which is larger, which is longer than, which is higher than the current value, so that you can directly delete it. So as the stack is empty, so that obviously there is no next smallest index, so that store the highest length, so which is 6. So length into the length into the array. Now so again, before moving on to the previous index, so you will load the current index 4, so which is holding the value as 2. Now if you closely say I'm at index 3, I'm at index 3. Now you know that I'm at index 3, and you know that whatever uh, whatever value which is present at index 4, so at index 4 you have value 2, so which is smaller than the current value. So that with respect to index 3, index 4 is going to be the next smallest index, so that 4, copy the index here. Now let's move on to the, so before moving on to previous index, store that index 3 which is holding value 6. Now let's move on to the previous one. Again, if you closely see this, so this is a tricky part. This is a tricky part. So you are at index 2 and having value 5.
రూమ్లో ఉన్నా.
You are having value 5. Now let's understand. So if you compare with index 3 value, so which is greater? So you want to find out a smallest one, right? So that you don't need this one, so that you can delete that. And after deleting that, you have a next value at index 4, which is 2, which is smaller than 5. So that obviously you can take this index, store here. It means if you see for index 2, the next smallest index is at index 4, which is having value 2, so that you can copy you can copy 4 here. Now before moving on to previous, load this current index 2 and the value having value as 5. Now you see in the stack you have two elements, this one and this one. So let me erase other parts. So these all already done. So these are only the two elements you have in the stack. Okay, now I am at so index 1. So let's compare. So in the stack you have closely see at index 2 you have value 5, which is greater than that, so that you can delete this. Similarly at index 4 you have value 2, so which is greater than 1, so that you can delete it. So it means you don't find any smallest index, so that obviously you can take the length of the array, so which is 6. Now let's move on to previous one. So before moving on to previous one, what is your job? You take the current value into the stack. So at index 1 you have value 1. Now let's see, current index is 0, you have value 2, and which is greater than the element present in the stack, so that it is at index 1, so that for 2 the next smallest index is 1. Now see, do you understand? So we just constructed next smallest index for each and every index, correct? Correct?
Yes.
So what is the time complexity here, Kalyan?
I mean, we are traversing the whole
Array.
given array to be linear, I would say.
It is linear, but we are also comparing on the stack, right?
Yes.
So when you are comparing on the stack, what is the time complexity here?
I mean, we might visit the elements twice in the first place.
Yeah. So every element, you see what one time you are keeping, other time you are deleting, right? So once you delete, you don't revisit the element again, right? Because it is out of the stack. So in worst case, you can visit element only twice. So definitely it is going to be big O of 2n, right?
2n, yes.
Ajay, clear?
Yes.
So it is big O of 2n. Now let's find out the same way for next previous element, previous index. Next, sorry, what is it? Yeah, next previous index. Previous smallest index, right? You can say previous smallest index. Okay, so same thing. So you will go with the same process. But it is just a reverse, right? So 0, 1, 2, 3, 4, and 5. So obviously for 0, you don't have previous one. So definitely it is going to be -1. And let me apply the same concept. Actually, if you solve that next greater element, right, my job could have been much easier. I think you didn't solve it. That's why you feel little bored. Okay, so now I am here. So for this there is no previous, so definitely it is minus 1. So when I am here, so what I am doing, so again I need to find out next, sorry, previous smallest index, right? So it means at index 0 you have 2. Now the current value is 1, right? So current value is 1, so which is greater than, so whatever value you have on the stack which is greater than current value 1, so definitely you can delete it. So as the stack is empty, again you will keep what, minus 1 here. It means here you don't have any smallest index to the previous. So when you are here now, before moving to the next index, you keep the index 1 here, and you will also have the value 1 here. And you see here you have at index 2 you have value 5, which is greater than the previous one, so that you can directly take the previous index from the stack, so which is 1. It means for index 2 the previous smallest index is at 1, so obviously you have 1. At index 1 you have value 1 which is smaller than 5, so you can take 1. Now you take the index 2 and it is holding the value as 5. Now when you go to 6, now right, if you closely see for 6, in the stack you have index 2 which is having value 5, so which is less than 6, so you can blindly consider that, so you can take that index, so 2 you can keep. Now before moving further, so you take the index 3 which is having value 6. Okay, so let's move further. So I am at index 2, sorry, I am at index 4 which is having value 2. Now this is our observation. Now you see what is the previous smallest index, right? So first you take the value 2, compare with value present in index 3, so 6 is greater than 2, so that you delete it. Okay, so let me delete it. Similarly at index 2 you have value 5, so 5 is greater than 2, so again you delete it. Now you have a stack. In the stack you have only index 1 and value 1, so which is obviously less than 2, because at index 4 you have 2. So the next smallest index, previous smallest index you find as 1, so that for index 4 take that 1. Now when you move to the 3, when you move to 3, so find out previous smallest index. So you have 3. In the stack you have index 1 and which is having value 1, so which is which
Before
is
that, we push in
Yeah, we need to push the previous one, right?
I forgot. Yeah, the previous one.
4 to index 4 value.
So 4 and 2. So now if you closely see at index 4 you have value 2 which is smaller than 3, so that you can consider index 4 here. So what is the time complexity of this?
Same order of 2n.
So again it is order of 2n, right? Okay, so you have order of 2n. Now once you know next and previous index, right, then it is our job, right? What is our principle? So next smallest index minus previous smallest index minus 1 into height of that index. That's it. If you closely see, obviously here you have 1 minus, so if you closely see, this is 1 minus of minus 1, so you will get 1. Hope you are able to understand, right?
Yeah.
Let me do it for everything. So for this one, so which is going to be 1 minus of minus 1 minus 1, so obviously which is going to be 1, so 1 into the value 2, so you will get 2 here. So current max area you get 2. Then again you have here, so here it is 6, here it is minus 1, so that it is 6 minus of minus 1 minus 1, so definitely it is going to be 6 into 1, so which is going to be 6, because height is 1, right? So max is going to be 6. Now when you are here and you compare with this, so which is going to be 4 minus 1 minus 1, so which is going to be 2, 2 into, at index 2 height is 5, right? So 2 into 5, so which is going to be 10, so max is going to be 10 now. Similarly for this, right? So you will get max as 10, correct na?
Yes.
So what is the time complexity you get here to find out max area?
Order
Big
of
of
n.
n, right? So total complexity is what? 2n plus 2n plus n, so which is going to be big of 5n, right?
Yes.
So what is the space complexity?
Taking 2 stacks and 2 arrays, I think.
So two stacks and two arrays, correct? So
Yes.
obviously which is going to be 4n, right? So if you consider, of course, stack, you can, at least it is 3n. even if it is increasing or decreasing order, but you can consider as 4n. So let me do that. So what is our job? So we are going to design additional two methods. That's it. What is our job? So we are going to design two methods. One is which is going to return
In the
next,
smallest index.
yeah,
Return next smallest index.
next smallest index for a given input. Okay, so heights. This is one, and you are also. It is a combination of multiple problems. Yeah, so one is previous smallest index for a given array. So what is our job now? Simple. So you will take an integer array of same length. Integer n equal heights dot length. Okay. So obviously, so for next smallest element means you should start from right. So definitely for the last element always it is going to be n only, because you don't have any element to compare. So what you can do, so you can start from index n minus 2 and n greater than or equal to 0. Sorry, index, right? Index minus minus. Then what is our job? So we'll also maintain a stack of integers.
No, n minus 1 is equal to n. We wrote
30.
instead of
Yeah,
6.
yeah,
30.
yeah. Yeah. So what is our job now? Okay. So we need to find out, right? So you will always push stack dot push off. Only I will maintain only indexes in the stack, because we already consider n minus 1 here, right? So just push that n minus 1 into the stack. Other things will be smoother now. So now you just need to see, as long as your stack is not empty, and whatever element you have on the stack, right? In the stack you always maintain only index, right? So you can have stack dot p, whatever element you have on the stack, if it is greater than the current element, right? So if it is greater than, you need to find out smallest index, right? If it is greater than current index, height of current index, then you can blindly delete it, right? Yes or nobody?
Yes.
Correct, na Ajay?
Yes.
So you blindly delete it. So once you delete it, then you need to find out the next smallest index for a current index, right? So you can have the result of current index. So you know that if the stack is empty means definitely which is going to be n. Otherwise, whatever index you have on the stack, you just take it, and finally you push this the current index for the previous elements. Clear, na?
Yes.
So finally you will return result. Similarly, same thing to the next smallest one, but we just need to do reverse, right? Yes or no?
Yes.
So we need to start from 0. For result of 0, previous is going to be minus 1,
Minus 1.
and you will have 0 here, and you will start from 1, and which is less than n, and index plus plus. This remains same, na? So if the whatever you have, if it is greater than this, you delete it. If it is empty, you have minus 1, otherwise peak. Done. So you can return this response. Clear, na?
Yes.
Once it is done, so what is your job now? First you need to find out both two arrays. So next smaller index array, so which is going to be get next smallest index array for a given heights, and similarly previous smallest index for given heights. Okay, then once you get it, so what is our job now? So you will start from index starting from 0, index less than n, index plus plus. Then our max area is going to be math dot max of max area. So you know, right? So I am directly writing it. Hope you can able to catch it. So next smallest on this index, whatever value you have, minus on this index whatever you value you have, minus 1 into the element height of this.
Height of index.
Yes, yes, and
So that's it. So let me run it. Okay, wrong answer. Let's see. 1 1 expected 2. So what's a mistake here? 1 1
We are not
expected.
considering the current one.
Not the
equals
current
to
one. So we are considering. So
equals to y field. No.
1 1 it failed, right? Where is this? If I apply greater than or equal to, then it will be wrong. So, so what is happening in this case? It won't delete, as it is not deleting it. Yeah, it should be greater than or equal to, right? Yes or nobody? Smallest index now you need to find out. Equal to means it's not going to be small, right? Yes or
Yeah,
no?
it should be greater than equal to, yeah.
So tricky. Yeah. But do you think this is acceptable solution? Yeah, it is accepted, but can you improve this? Or I will write the improvement code so that this is a complete stack problem. If you are solving this problem means you understand stack really well. So it is going to take 5 n, right? But can you improvise this? Now you know. Now you know. You know how to solve this solution, right, Ajay, Kalyan?
Yeah.
Now you know how to
Yeah.
solve this solution. Now let's write the optimization for it. So what happens? Okay. Okay. So let me take the same input 215623. So let me write the optimization. So 215623. Okay. So 0 1 2 3 4 5. Okay. So let me write the diagram here. This is 2 1 5 6 2 and 3. So one thing for sure, for a given index I need to find out next smallest index and previous smallest index. Once I know these two values, then the answer is going to be next smallest index minus previous smallest index minus 1 into height of the current index, correct? So we need to calculate, consider on max area. Right, so let's see how can you do that. So I am at zeroth index, 0, 1, 2, 3, 4, 5, right? So I'm the complete solution what I did, so I'm trying to solve it in a linear time, but using the same concept, but I will use single stack and figure that out. So how do you do that? So let's move on. Okay, so I am using the stack. Okay, so this is my stack. So this is my stack, and I also know that the max area I could see right now, which is 0. So right now I'm crossing index 0. So at index 0 stack is empty. So when the stack is empty, what is the previous smallest index if the stack is empty as per our
minus
answer?
1.
Okay, so
minus
nice. So PSC is minus 1. What is the next smallest index if the stack is empty?
The current element.
Yeah, so this is where we need to apply a little sensible logic. So let's move on. So first I have only element 2. Okay, so I have only element 2. So let me copy here. So you have element 2 at index 0, which is having element 2. So this is my stack. Okay, so let it be. I don't find any next smallest output because I don't know when do I know that. So for this I know previous smallest index because stack is empty, so definitely I can say that it is minus 1, but I don't know when is the next smallest index, right? When I am at 0, correct na buddy?
Correct.
So
correct.
so that's why what we do, don't pre-calculate now. So right now you have 0, so 0 with the index 0 you have value 1. Okay, now when I go to 1, when I go to 1, so I am at index 1. So at index 1 you have value 1, right? So at index 1 you have value 1. Just a minute, bro. I'm thinking of can I avoid these two arrays? That's what. If I am unable to avoid these two arrays, then if I want to use these two arrays, it will be simple. I'm just thinking of can I avoid those two? Mhm. Okay. Just a second. Thinking of it. I need to find out next smallest, previous smallest. Yeah, I got the. Just a minute. I am here. Meantime, you will also think. I'm also thinking. Okay. Mm, perfect. So let me explain the thought process here. Okay. So initially I am at index 0. Initially I am at index 0. I don't know what is the next smallest element to this, but I know what is the previous smallest element, but I don't calculate that. So I am storing index 0 and which is having value 2. Now, when I am here, right? When I am here, the current value, if you closely see, what is the current value, buddy? 1, right? Which is
1.
smaller than 2, right? Which is
Yes.
smaller than 2. I understand that the current is next smallest index for 2, correct?
Yes.
I am at, so this is more important observation. I am iterating index 1. When I am iterating index 1, I already loaded 0 to the stack. Now when my current element is less than the top of the element, to this top element, this is going to be the next smallest element, right? Yes or no?
Yeah.
Perfect. So now I understand that. So now I am trying to process for index 0, you have value 2. So I know that next smallest element is going to be current index is going to be current index, so which is 1. Now I need to find out previous smallest index, right? So for this element, so closely understand, I didn't complete this iteration. I am trying to find a solution which is already present on stack. So in the stack, now I understand that this is the next smallest index, so that I want to find out for this what is the previous smallest index. So I just need to find that out. So what I will do, I will pop it. Okay, I will pop from this. Okay, so I will pop this 2 from the stack. Okay, I pop 2 from the stack, so that I have element 2. Okay, so in the I pop it from the stack, so that which is holding the element 2, it means now stack is empty, right? As the stack is empty, for this element 2, it means which is present at index 0, as the stack is empty, the previous smallest index is going to be minus 1, right? Yes or nobody?
Right, because it's empty.
Because it is empty, I am calculating with respect to the top element present on the index, so present on the stack. Got it? Not with respect to 1. Clear, buddy? Kalyan?
Can you please come again once?
So what I'm trying to do, so first what we did, so I'm repeating the algorithm again, so please
Okay. Okay.
yeah, so initially I am at index, so initially I am at index 0, right? So I am at
Yes.
index 0. Now I don't know what is the next smallest index for this 0. Okay, so
Correct.
what I'll do, I'll store index 0 to the stack, and it is having holding value 2. Now when I move on to the next iteration, I am having value 1, right?
Yes.
So which is smaller than top value present in the stack, right?
Correct.
It means this is going to be the next smallest index, right? For this element,
Yes.
correct?
Yes.
So it means
Yes.
for index 0, you have in the stack, so which is top. So first what I will do, I will pop it from the stack, because I already know for this next smallest index is current index, which is 1, correct?
Yes.
Index, okay, this is index. Okay, now I want to find out previous smallest index. So previous smallest index, how do you find out? First I pop it, I got the value 2. And if I have a value in the stack, that is the previous smallest. As I don't have value in the stack, definitely it is going to be minus 1, right? Yes or no?
Yes.
While writing the
Yes.
logic also we did the same, right? So now
Correct.
you know next and previous, and the current element also you know 2. So 2 into next minus of minus 1, so which is going to be 2 into 1, so which is going to be 2. So it means the max area as of now you calculated as 2, right? And you understand that we processed this index, right? Yes or no, buddy?
Yes.
We
Yes.
process this index. Okay, so closely understand, so which is more important. Okay, we process this index. Now let's move on. Now when you are moving on, keep the current element in the stack. So index is 1, which is also having value 1. Okay, so now I am moving on to the index 2. Now if you closely see, at index 2 you have value 5. This is not smaller than the top element, right? Correct, na, buddy? Yes or no?
Yes.
So again you keep that value into the stack. So index 2 you have value 5. Now let's move on to the next index. In the next index you have value 6, right?
Yes.
So value
Yes.
6, which is not great, which is you need to find out smaller index, right? So definitely,
Smaller.
so you keep this index 3 and store into the which is having value 6. Now when you move further, closely see, to the current index you have 6, right? Sorry, to the current index 4 you have value 2, correct? So this is more important observation. You have value 2, and if you consider the top element, which is 6, so you found out a smallest index for 6, right? Next to smallest index for 6, right? Correct?
Yes.
Exactly.
So you found out a next to smallest index for 6. Okay, perfect. So what I did, first I will pop this value from the stack. Okay, so which is popped. So you have element 6, and you know next to smallest index is going to be the current index, current iteration index, which is 4. And what is the previous smallest index? 2 only, na? Yes or no, buddy? For 6, previous smallest index is 2 only, na?
Yes.
Which is
Yes.
already present in stack, right?
Correct.
Sure.
Yes or no? So previous smallest index is take the top value from the stack. Okay, so which is 2. Okay, take 2. Now you found the answer 4 minus 2 minus 1, which is going to be 2 only, no? What is it now? 1, 1, right? So 1 into
1.
6, so which is going to be 6, right? So for this you get 6, so you update the max area 6. Now again, see for the previous value, it means closely understand, so current index is, you found a smaller index for the current index, and 2 is also smaller for the current index, right? Yes or nobody? Even for
Yes.
element 5, index 2, you have element 5. For this also, this is the smallest index, right? Yes or no?
Yes.
Kalyan.
Yes.
So you processed this.
Yes.
Okay, so once you process it, just tick mark. So you process this and you process this. Now you want to process this one. Okay, closely understand. So this is more important. So in the stack you have elements. So index 2, at index 2 you have value 5, and 5 is greater than 2. It means you found a current index is next to smallest index for 5. So again, what is your job now? Again you pop this element. Okay, so let me pop this element. Okay, so let me erase this. You pop this element. So once you pop that element, so you have element as 5, and you know that next smallest index is going to be current index, which is 4. And what is the previous smallest index? What is the previous smallest index? 1, right?
1.
Which is already present in
1.
stack, right? Yes or no?
Yes.
Yes.
So while building the stack only, we build in increasing order. So right. So again, 4 minus 4 minus 1 minus 1, so which is going to be 3, right? So definitely 3 into current high. Sorry, I did a mistake.
2.
Next smallest index is 4. Okay,
4
so
minus 1 minus 1 into 5.
yeah, so which is going to be 2. So 2 into 5, so which is going to be 10, which is greater than max. So take 10. Now again see in the stack what you have? 1, right?
1.
But the current element is what? Current
2.
element is 4, so 2, right? So which is not
2.
smaller than 1, so that your stack contains 1. So these will be deleted, right? So your stack contains 1, and now you move on to the next index. Before moving on to the next index, you load the current element. So index 4, you have element 2. Now let's move on to the next index. Now when you move on to the next index, you see what is the value you have? 3. So which is greater than the top element, right? So it's not the next smallest element. So you have 5 and 3. Correct now, buddy?
Yes.
Now
Yes.
if you closely see, somehow you have value 10, but your stack is still having data, right? Yes
Yes.
or no? So it means sometimes your stack also can have the data. So one thing you should understand, that you don't find for this index 1, index 4, if you closely see, for index 1, index 4 and index 5, you don't find next smallest elements on the stack. Correct now, buddy? Yes or no? Ajay?
Yeah.
So for index 4, you don't have next smallest element. Index 2, you don't have next smallest index. Index 1, you don't have next smallest index. So it means what is the next smallest index for this?
Minus 1.
Next, that is previous is minus 1. Next is n,
Next
right?
is 6.
N.
N,
Next
right?
is N.
Right? So then what is our job now? So later what you do? So first you pop this element. So once you are done with complete processing, take the stack, pop this element. You got element 3, and n is 6, right? 6 minus. What is the previous smallest index for this?
2.
4, right? Index 4, right? Yeah, 2 means it is at index 4, which is already present in stack, right? Yes or
Yes.
nobody? So it means 6 minus 4 minus 1. So definitely which is going to be 1, right? So definitely you have 3. So 3 is smaller than max. Again you move on to the next one. So you at index 4 you have value 2, right? So you got value 2, and next smallest index is 6. Next smallest index is m, which is 6. What is the previous smallest index? 1 only, na? Yes or nobody? So that is
Yes.
already present in stack, right? So for 2, the previous smallest index is at 1. So 6 minus 1 minus 1, so definitely which is what?
4.
That would be 2.
Did I do a mistake? Previous is 1 only, na? 4.
6 previous smallest is
I am at 4, right? So 4 previous smallest is 1, right? Correct only, na? Correct only, na, buddy? So 4 into value is 2, so which is going to be 8, right? Yes or no?
Okay.
Yes, na, Ajay? Don't get confused.
yeah.
So it is
Got it,
smaller
yeah.
than max area, so definitely 10 remains here. Now again you get into 1, right? So now it's time for us to process this index 1. So element is 1, index also 1. So obviously next is 6 and stack is empty. What is the previous, buddy? So when you pop this, stack becomes empty, na?
Yeah,
Yes.
stack is
So
empty.
then if it is stack, previous is minus 1, right? Yes or no?
Yes.
Minus 1. So
Yes.
which is going to be 6. So 6 into 1, so which is 6. So which is greater, smaller than 10. So you just return 10. So now can you tell me what is the time complexity?
We just took a
So
stack.
yeah.
So first of all, we are
Mhm.
traversing it, right? We are traversing the
Yeah.
complete array.
And coming back again, checking.
So big O of n, and we revisit every element at max twice, right?
Yes.
So
Yes.
2n, correct?
Okay. Yes.
And what is the space complexity?
It's
I think we
n
just
and the range.
It's only the stack, right?
Mhm.
It's only the stack we use, so which is going to be n. Correct, na?
Yes.
Array, let me write it. Since last 1.5 hour, I am standing now. Okay, so what is our job? So you found next. Let me remove this data, this code. But if you don't solve this code right, then you can't write the code which we are trying to do. Okay, so what is our job? We'll start.
This definitely needs good understanding of stack. Otherwise, it's very, very, very difficult.
Very tough problem. One of the toughest problem it is.
Yeah.
It means you need to be very clear about data structure, not
Correct.
the algorithm, not the problem.
Problem. Yeah.
If you could have solved these problems right, I think none of them solve these problems. So if you could have solved those problems, for me it was very, for me today it was cakewalk. Did you
Mhm.
solve these problems? I think you didn't. That's why it is taking little time. Which is less than n. Can you tell me the code? What is the job? What is the job I should do now? Can you tell me the
Sure.
code?
I think we have to insert the first element first.
Hmm. So while, so first, uh, so what are we doing here? That's okay. You have to insert the first element or not. Okay. Uh, while stack is not empty, for sure we should process it. Is not empty. Okay. And what is the next thing we should do? If the current element is less than the top of the stack element, you find a next greater element, right? Next smallest index, right? Yes or no?
Mm.
That's
Yes.
what we did, na, Ajay?
Yes.
Height of stack dot peak, whatever value present on stack, if it is greater than uh, current one, right? Uh, What is the
Yes.
current one? It is heights
Height of
of
index.
index. Then now you know that. So next smallest index is going to be the current index. Correct? Correct, na?
Yeah.
And what is the element? So what is the element you have? So on the stack dot peak, whatever you have, so you just pop it from stack. You got the index. So this is your element. This is your element. For this element, the next smallest index is current index, and we also need to find out what is the previous smallest index. So which you can do if the stack is empty, then it is -1. Otherwise, stack dot peak, right? Correct, na?
Yes.
Yes.
Now it's time for us to calculate the max area. So max area
Minus I minus the previous I.
into element. Done. So then what is our job? So once you are doing all these stuff, then finally you will add the current index to the stack, right? Correct, now, buddy?
Yes.
Then what is our job? Now again you have to recalculate. So as long as your stack is not empty, if there are elements in the stack, right? So then you don't find a next smallest index on the right? Correct, na? Correct, na, buddy?
Yes.
So first
Yes.
first you will get the current element. So current element is going to be the same. Let me copy this. And next smallest index is always going to be n, right? If stack is empty,
Length
which
of
is
the.
n. Otherwise previous smallest index. Okay, so this is same. So if the stack is empty, it is -1. Otherwise that, then finally you will calculate this area. Please practice this problem. I thought of completing 2-3 problems today, but this itself took long. That clear, na? Code is clear, right?
Yeah.
Yeah, actually my voice should low down, man, but your voice is getting low. Okay. So
That shows how difficult the problem is.
yeah.
Who? It's really hard.
I mean, not the code part. When you're drawing the diagram itself, that time if you're able to understand it, then code would have been easy.
Or did I explain
Yeah.
properly, or did I made you complicate?
No, it says we have not practiced.
Hmm.
That's the root cause.
That's a root cause. Actually, I have organized the problems in a well structured manner.
Yeah.
The problem is if you don't practice right, then it will be tough. Tomorrow we will complete next 3 problems. I think we can complete tomorrow, so that you can have Saturday, Sunday practice all these stack problems. From Monday onwards, we will freshly start Q.
Sure.
Oh, it is recording.